This will be an overview of temperature sensing and converting circuit. I'm using a TMP36 temperature sensor and an LM324 Quad Op Amp. The TMP36 sensor has an output in voltage that corresponds to degrees in centigrade with an offset, and we will use op amp to both correct that offset and convert centigrade to degrees Fahrenheit as our final output. I will pan the circuit so you can have an overview of all the components, and then I will address each major component in detail. So the first component is the Lm24 Quad Op Amp. We're going to power that with two 9-volt batteries connected in a series, and that will provide dual voltage to the op amp, plus 9 volts on this side, negative 9 volts on the other. The op amp is capable of operating off single voltage, but providing dual voltage seems to make it a bit happier. The next major component is to provide power to the temperature sensor. Basically, we will take 9 volts of input voltage and use voltage divider circuit to get that down to 3 volts in the power input rail for the sensor. We have the ground here, and the output rail for the sensor will also go through a series of resistors before it gets inputted into the first op amp. The third major component of this circuit is power supply for the reference voltage that we need for the conversion to Fahrenheit. We will provide that reference voltage with a 3-volt battery, which goes through a voltage divider consisting of 1 kilo ohm resistor and a trim pot adjusted to about 355 ohms, and that will output a voltage of about 0.785 volts, which is the value that we need for the conversion. What we also will do is we will take that voltage output and run it through a buffer op amp so that the op amp following that will see the voltage as a signal only with little or no current. So now the circuit is powered up. We have the 3-volt reference voltage input, and for comparison I have a sort of a garden thermometer, not the most accurate thing, but it's indicating that the temperature in this area is roughly just over 65 degrees, and corresponding to that we have 0.6465 volt, which equals 65 degrees Fahrenheit. So the circuit seems to be pretty accurate. And now what I'll do is I'll run a hair dryer just to increase the temperature, and we'll see how the corresponding temperature on the voltmeter increases. Please excuse the noise. So you can see the temperature increase from the the hair dryer. The garden sensor is very, very slow, so it does not respond as quickly. But we can see that the temperature goes up under the hair dryer and it's now dropping back down to the previous value. In a few minutes, it should go back down to about 65 degrees.